Hello and welcome to my YouTube channel. Newton's second law of motion. Batting karni hai, bowling karni. Catch the ball like this. This way of catching hurts. This is the case. The rate of change of momentum of the body is directly proportional to the applied force and takes place in the direction in which the force acts. So if you have a body of mass m and a force F is acting on this body for some time interval, say delta t, and if the initial velocity of the body is v, then under the influence of this force, this velocity will change to v plus delta v. That is, this velocity will change by this much amount after this force has been applied for this duration of time. That means that if the initial momentum of the body was this, the change in momentum will be this. And according to the second law of motion, this force is directly proportional to this rate of change of momentum with time. Or you can say this force is equal to some constant times delta p by delta t, where this k is the constant of proportionality. Taking this limit tending to 0, we have force equal to k times dp by dt. That is, this becomes the differential coefficient of p with respect to t. Or you can also say this derivative of p with respect to t. So this F, you are saying that it is equal to k times dp by dt, and this p is nothing but this. So F is k times d by dt of this mv. And you know that acceleration was rate of change of velocity, and if you do not know, you can go back and check my previous videos. You will definitely get some idea. So this force is now equal to k times, and this m is also constant, so this is d by dt of v, which is nothing but the acceleration, such that force comes out to be equal to this constant of proportionality multiplied by mass into acceleration, which shows that this force is proportional to the product of the mass and acceleration. So this constant can be given any value. For simplicity, we choose this k equal to 1, and on choosing this k equal to 1, we have this basic equation for the Newton's second law of motion, which states that force is equal to mass into acceleration, or force is equal to rate of change of momentum. The SI unit of force is Newton, and you can analyze it as, you can define 1 Newton as the force that would accelerate an object of mass 1 kg to an acceleration of 1 meters per second square. So this means that 1 Newton is equal to kgs meters per second square. What are the points that we conclude from the second law of motion? First point is, if the force is 0, the acceleration is 0. And this is in accordance with the first law of motion. The second law of motion is a vector law. That means if I'm talking about force is equal to mass into acceleration, so I also need to talk about the directions. This means that we have a force F in x direction equal to the rate of change of momentum in the x direction, and mass into acceleration in the x direction, and likewise. So this momentum is nothing but mass into velocity. So what do we conclude from this? So for example, if you have a body of mass, say m, and this is moving in some direction, say this horizontal direction v, and you have a force that is applied on this body, which is not parallel to this velocity, but it is forming some angle with this. Now let us see how we can interpret this. You know that parallel translation of a vector does not bring about any change in it. So this vector can be translated here, and if I put this force here, this force is this, and it is making an angle theta with this velocity vector. Now what these equations suggest you that if you take the components of this velocity vector along the direction of the force, and in a direction perpendicular to this force, these will be v parallel and v perpendicular. So these equations will only consider the component of the velocity vector which is along the direction of the force, which is parallel to the force applied, and the component of the velocity which is normal or perpendicular to the force applied remains unchanged. This component remains unchanged. So the second law of motion is applicable to a point object, single point object, like the net external force applied is equal to the mass of this point object and the acceleration of this object, point particle. So it turns out that, however, this law is also applicable to rigid bodies. This law is applicable in the same form to the rigid bodies as well. In that case, F refers to the total net external force and A refers to the acceleration of the system as a whole. So more precisely, this acceleration A of the system is actually the acceleration of the center of mass of the system, regarding which we will be talking about in our subsequent videos. And any internal forces are not included in this force, in this F. It is only the net external force. All the internal forces, they kind of get cancelled and they are not included in this F. Finally, the last point that I would like to discuss over here is the second law of motion is a local relation. The force at a point, the force acting on a point in a space, this point is in some space. If the force is acting on this point, that is equal to the mass of this point and the acceleration at that very instant. Force उसी वक्त पे is equal to the mass and acceleration उसी same वक्त पे क्या थी? The relation between the acceleration and the force is based on that very instant. It is not dependent upon the history of the accelerations of that object. Acceleration at that instant is determined by the force at that instant. So let me give you an example. If you have a train and a person is standing, a train is having some acceleration in a horizontal direction and a person is standing like this. Obviously, everything that is in this train right now at the moment is having an acceleration in the horizontal direction, which is the acceleration of the train itself. Now, if that person drops this stone, if this person drops this stone out of this accelerated train, and if you neglect any air resistance, this stone will have no horizontal force and no horizontal acceleration. Because at this moment, the only force that is acting on this stone is the gravitational pull of the earth, the gravitational force, and it is acting in the vertically downwards direction. The acceleration is in the vertically downwards direction. So the only force acting on this body is the gravitational force, and the stone has no memory of its acceleration with the train a moment ago. So that was all for today. I hope you enjoyed the video, and do not forget to like this video and write your beautiful comments in the comment section below, and I'll be back with my next video. Till that time, you do not forget to take really good care of yourselves, and please do not forget to subscribe to my channel. And if you are new to my channel, hi, this is Pooja and I make videos on topics related to physics and life.